Okay, Unit 4, Day 8. There's only 3 days left. 8, 9, and 10. That's 3. I know you're going 10 minus 8. That's 2. There's 3 days left. 10 minus 8 is 2. And I'll also be doing a video of the practice test. Or the test, actually. Excuse me. Let's get started. Let's solve radical equations. If you remember from my last video, my pen was not working very well. Hopefully I have fixed that issue, and it is working much better now. Solving radical equations, whether it be a cube root or a square root. The first thing you must do is isolate the radical. That's the first thing. Make sure that the radical is all by itself. Well, in this case, I'm good. I'm done. Next thing you want to do is take and square both sides. Now, you have to remember that sometimes when you introduce squaring of a radical, you have introduce what are called extraneous roots. There are certain restrictions on radical functions, and that is you can't take the square root of a negative number and get a real solution. So sometimes when you square root things, or when you take the square of things, you eliminate that restriction and you introduce extraneous roots. So when you're dealing with square root functions, you must simply check your answer. A radical, a square root, and a square, they eliminate each other. Remember, the square root function, that exponent is really a half. So a half times 2 is just 1. So I end up with just 5x plus 1 equals 36. And now you solve this as you normally would. This, subtract the 1, bring it over, you get 5x equals 35. Divide by 5, and I get x equals 7. Now I should check that. Throw a little check down here. The square root of 5 times 7 plus 1. Well, 5 times 7 is 35, plus 1 is the square root of 36, and that, of course, equals 6. So checking, check. Let's go to 2. Number 2. Okay, so number 2 is a little bit more difficult because on the right I have a binomial that I have to square. And I know what you're thinking. X squared plus 1. But not if you're in my class. In my class, you know, I'll make fun of you, I'll belittle you, I'll make you feel really awful about yourself. No, I won't. I'm just kidding about that. You'll remember that a binomial, when you square it, you have to write it twice and you have to double distribute. Some places they like to call it FOIL. Double distribute, FOIL, it doesn't matter. We're going to square both sides. So when I square x plus 21, or the square root of x plus 21, I don't know why I'm saying x like that. It's really annoying. I get x plus 21. And on this side, this is not a double distributing lesson, so I'm not going to go through a lot of the double distributing. I think you know how to do that. You'll end up with x squared plus 2x plus 1. This gives me x. This gives me x. That's 2x. It's a quadratic, so I want to make sure my x squared is always positive. So I'll move everything to the right side, so I get x squared. If I subtract x, when I bring that over, I get plus x. When I subtract 20, I get, I'm subtracting 21. I was already getting to the answer. I get minus 20. All right, got a factor. X plus 5, x minus 4, they factor. Gives me two solutions. X equals negative 5, and x equals positive 4. You must check your solutions. So let's try it. We'll check right over here. Maybe we'll do it in blue. Green, still around Christmas time. Check. Yesterday was Christmas. So, negative 5 plus 21. That's the square root of 16, which is, 4. Now, if I plug in negative 5 on the right side, I get negative 5. Does that equal negative 5 plus 1? No, because that's negative 4. So this solution doesn't work. Let's try 4. The square root of 4 plus 21. That's the square root of 25, which is 5. And on the right side, I get x plus 1, which is 4 plus 1. That's 5. Ka-ching, that checks. Now, in order to eliminate, again, we have the cube root by itself here, but in order to eliminate a cube root, you must cube this side. You must take the cube of that side. And so that's what I'm doing. I get x minus 16 equals, well, 2 cubed is 8, not 6, 8. Add the 16 over, and I get x equals 24. I'm checking all of these. Check all of these. The cube root of 24 minus 16. Well, 24 minus 16 is 8. The cube root of 8 is 2. Cha-ching! Checks. All right. So we're going to start entering into where we need to start looking at isolating the weird thing, the radical in this case. In this case, this 6 is in the wrong place, so I need to bring that over. I'm going to put my checks in green, in my work in red, just to make it fancy. So I'm going to still take the cube root of 4x plus 2, but in this case, it's going to be equal to, okay, let me see, add 6, I get negative 4. So now I'm going to cube, that's a cube, cube both sides. And let's see, when I cube this side, I just get 4x plus 2 equals, and then negative 4 cubed is negative 4 times negative 4 is positive 16 times negative 4 is negative 64. Subtract 2, I get 4x equals negative 66. Divide by 4, and I get x equals negative 66 over 4, which is fine. Unless they say rounded to the nearest hundredths or something like that, that's fine. Let's check this. I know what you're thinking. Fraction. I got a stupid fraction. Actually makes life rather simple. It's 4 times negative 66 over 4 plus 2 minus 6. And we want to see if that equals negative 10. Well, here the 4's cancel, so that's cool. And negative 66 plus 2 is, well, that's negative 64. And since the cube root of negative 64 is negative 4, and negative 4 minus 6 is negative 10, it checks. So here we got a couple things to do. First thing we got to do is bring this 3 over. So we're going to subtract 3, and I get 12. So I get negative, I don't know what that is, negative 4, the cube root of x plus 10 equals 12. But I can't do this. I got to get rid of this negative 4. Divide by negative 4. And divide by negative 4. And I get the cube root of x plus 10 equals negative 3. We're going to cube both sides. And so I get x plus 10 equals negative 27, or x is equal to negative 37. That just doesn't seem right. I don't know. Let me check this. Negative 4. I don't know why I keep doing that. Negative 4, the cube root of negative 37 plus 10 plus 3 equals 15. Let's see. So this is negative 4 times the cube root of negative 27 plus 3. Well, isn't the cube root of negative 27 really just negative 3? And isn't negative 4 times negative 3 positive 12 plus 3? So I end up with 12 plus 3. And of course that equals 15. All right. Isolate the radical. 2x minus 1 equals 3. You have to square both sides. So I get 2x minus 1 equals 9. Bring the 1 over, I get 2x equals 10. So x equals 5. Going to check it off to the side here. 2x minus 1 plus 1. Hopefully this turns out to be 5. So this is 2 times 5 minus 1 plus 1. Well, 2 times 5 is 10. 10 minus 1, oh, it's plus 2. Just about to get the wrong answer. So this is the square root of 9 plus 2. And you know that's 5. We're done. We're done. Okay. Well, that looks crazy. It looks crazy difficult. Not at all, kids. You can handle it. Still going to do the same thing. We're going to take the square. We're going to square both sides. Well, in this case, squaring 1 is kind of easy. And squaring the left side is kind of easy. You get x squared minus 3x plus 3 equals 1. We'll bring the 1 over, so we get x squared minus 3x plus 2 equals 0. We'll subtract 1. Factoring is not bad here. X minus 1, x minus 2. So my two answers are x equals 1 and x equals 2. All right, let's check those. Oh my gosh, checking these. Let's do it. I'm going to try to do it like this. 1 squared is 1, minus 3 times 1 is minus 3, plus 3. Well, minus 3 plus 3 turned out to be just 0, and I get the square root of 1, and that's 1. Let's try 2. 2 squared is 4, minus 3 times 2 is 6, plus 3. Well, really that's negative 2 plus 3, which is 1. 1 plus 1 is, excuse me, square root of 1 is 1. That works as well. So we're good. Off to 8. This one's kind of a pain. Because to isolate this radical, you actually have to divide by 2 and divide by 2. So I get x over 2 squared, because I'm going to square both sides. If I get rid of this, now I'm going to square both sides. Just running out of room here. Equals 2x minus 3 when I square it. Well, on this side I get x squared over 4 equals 2x minus 3. I hate this 4, so I'm going to multiply everything through by 4. So I end up, I'm going to do it over here, I get x squared, because these cancel, equals 8x minus 12. I'm going to bring everything to the left side. X squared minus 8x plus 12 equals 0. I'm going to end up erasing to check this one because I'm going to run out of room here. All right, my factoring here is going to be pretty simple. It's x minus 4, x, I don't know why I put 4, x minus 6, x minus 2. So my two answers are x equals 6 and x equals 2. But I definitely have to check this. Let me do that over here. Just to make sure it works. So let me check over here. I want to know if 6 equals 2 times 6 minus 3. Well, 2 times 6 is 12. 12 minus 3 is 9. Square root of 9 is 3. 2 times 3 is 6. So I end up with 6 equals 6 here. Good. Now let's try 2. 2, does that equal 2 times 2 minus 3? 2 times 2 is 4. 4 minus 3 is 1. The square root of 1 is 1. 1 times 2 is 2. So they both work. Good. Both work. So we're going to divide by 2, so I get the square root of x to the 4th plus 12x squared equals 8. Then I'm going to square both sides. So I get x to the 4th plus 12x squared. Now in an effort to save a little bit of space here, I hope you can agree that that's 64. And we're going to end up bringing that to the left side. So we're going to end up subtracting and get minus 64 equals 0. Now this is where all the crazy crying comes into play, because you're having a hard time with this x to the fourth. It's factored exactly the same way as the other ones. Except instead of x and x, you're going to have x squared and x squared. And it's going to be a positive 16 and a negative 4. So let's check these. Or let's finish with these. This actually gives me two solutions. This is going to give me x squared equals negative 16. Take the square root of both sides. I'm going to get x equals plus or minus 4i. Here, I'm going to get x squared equals 4. Take the square root of both sides. I get x equals plus or minus 2. Those are the answers. Let me check these. Get rid of this. And I'm going to see if I got a little room here to check them for you. It's kind of tricky. 2. No, they all should turn out to be 16. Let's see. Let's start with the easy ones. 2 squared plus, 2 to the fourth plus 12 times 2 squared. Well, we need this thing here to turn out to be 8, because 2 times 8 is 16, which means we need everything underneath to turn out to be 64. So let's see, 2 to the fourth, that's 16. 2 squared is 4. 4 times 12 is 48. So that's 64. Square root of 64 is 8. 2 times that is... So that one works. Let's try the negative. Negative 2 to the fourth plus 12 times negative 2 squared. Well, that's going to be the exact same thing, because negative 2 to the fourth is 16. And then this is negative 2 squared is 4. 4 times 12 is 48. 48 and 16 is 64. Square root of 64 is 8 times 2 is 16. The imaginary is a little crazier, but not much. Not much. Let's see how we do this. Four I to the fourth minus, or excuse me, plus sorry, I thought I had all four answers written down. I know one of them's not going to work out, and I was wondering what I screwed up. Sorry about that. 4i squared. So let's see here. 4i to the fourth. That's going to be kind of tricky. Let's see. I to the fourth is just 1, so I don't need to worry about that. With 4 to the fourth, that one's kind of tricky. 4 times 4 is 16, times 4 is 64, times 4 is 256, I believe. And this one turns out to be, I squared is negative 1, so 16 times 12. I don't have my calculator up. I don't have it written down over there. I end up with 12 times, it turns out to be negative 16 is what it is, but we'll do 16 just for fun. Let's see, 12 times 12 is 144, so this is 168, right? Well, I unfortunately can't bring my calculator up, and I wouldn't give this one to you on a test. Positive 4i, according to what my works, and negative 4i does not work. So in this case, my solution would not have the negative 4i. It would be positive 4i, 2, and negative 2. Again, I would show you that on a calculator. Hopefully I'll be able to purchase that calculator later. I was having issues with that earlier, and then we'll be able to take a look at it. All right, let's keep going. Next one's going to have some i's in it too. We're not going to check the i's today just because I don't have time. We'll check the real solutions. So we get x to the 4th minus 3x squared. I really wanted to bring that up, but unfortunately I'm having trouble purchasing actually the silly software for that. That calculator, and my trial version is up, so we'll get a new one. Square both sides. I get x to the 4th minus 3x squared equals 4. Bring the 4 over. I get x to the 4th minus 3x squared minus 4 equals 0. And on this one, the factoring is kind of interesting, actually. You get x squared minus 1, x squared plus 1, and x squared minus 4. So my two solutions here are going to be x equals, well, you end up with x squared plus 1 equals 0, or x squared equals negative 1, which of course we know to be x equals plus or minus I. And that's why I'm not going to check the imaginary ones today. Over here, I hope that you see that you end up with, where did my thing go? X equals, because you could factor this to x plus 2, x minus 2, and you get two solutions. X equals negative 2 and x equals positive 2. Just for fun, just to save a little bit of time, I'm going to tell you that all four of them work. Plus and minus I work, plus and minus 2 work. Again, you would simply check these on your calculator. At least that's what I would do. Let's get to these. So, they're done the same way as the radicals. You just got to understand that this x to the 2/3, that's the thing that needs to get all by itself. You need to isolate that. So what I want to do is divide by 2, so I get x to the 2/3 equals 16. Now, getting rid of them, or getting rid of the radical, or isolating x by itself is a little bit different. What you want to do is you want to raise this to the reciprocal. Oops, 3/2. You're going to raise both sides to the reciprocal, 3/2. Now, you can either do this on the calculator if you choose, or you can remember that the denominator is the root, and this is the exponent. So if I take the square root of 16, I get 4, and 4 cubed is 64. And that would be your answer for that one. And yes, you should check these, but I'm going to assume that you can do that in your calculator, and we're going to move on. Here we're going to add the 73 because we have to isolate even whatever's being raised to this exponent, we have to isolate. So x minus 5 to the 5/3 power equals 243. Now what I want to do is I want to raise both sides to the reciprocal of 5/3, which is 3/5. Now everybody here knows that the 5th root of 243 is 3. You should, honestly. Why would I give you anything crazier than that? I mean, it's going to be either 2, 3, 4, or 5. It's not going to be anything crazier than that. So in this case, it's odd, and it doesn't end in a 5. So the 5th root has to be 3. 3 cubed is 27. So 243 to the 3/5 power actually turns out to be 27. I add 5 over, and I get x equals 32. This one's all set for me to go, so let me jump back to red. I'm going to just automatically raise this to the reciprocal, 6 over 5. 6 over 5. Now again, it's 32. What number can I take the 5th root of? Excuse me. What number, when I take the 5th root of 32, what could it possibly be? 2. And 2 to the 6th power, well, that's just 64. So add the 19 over, I get 5x equals, what was this, 83? Yep, 83. And I divide by 5, divided by 5. And I get x equals 83 over 5, which is perfectly correct. Moving on. This is really a square root. 1/2, remember, is the same thing as a square root. So really what I'm doing is I'm going to square both sides. 2 over 1. So I get 1/3 x minus 11 equals 25. Bring the, well, I'm going to multiply everything through by 3. So I get x minus 33 equals 75. Add the 33 and I get x equals 108. Almost done, kiddies. I think we got 2 left, right? All right. So we got a couple things to do. We have to isolate that 2/3, that x to the 2/3. So we're going to bring the 8 over. So I get 3x to the 2/3 equals 27. Then I'm going to divide by 3. So I get x equals x to the 2/3. Let me write that better. I'm going to actually show you the work because I want to make sure you understand it. We're going to divide by 3. And I get x to the 2/3 equals 9. Now I'm going to raise both sides to the reciprocal, 3/2. Now remember that bottom is the square root cubed. So the square root of 9 is 3. 3 cubed is 27. So my answer is x equals 27. Almost done, kiddies. I don't think there's another page. Nope. I'm going to add the 20 and bring it over. So I get 5x to the 3/5 power equals 320. I'm going to divide by 5. And I get x to the 3/5 power equals 64. I'm going to raise this to the reciprocal, which is 5/3. So I need to take the cube root of 64. Well, the cube root of 64 is 4. And now I need 4 to the 5th power. So 4 times 4 is 16. Times 4 is 64. Times 4 is 256. Times 4 is 24. So the answer here is 1,024. And that's it. That's all she wrote. We are finished. Congratulations. We got day 8 done.